Hey everyone. Hello. Hopefully you can all hear me. Hello. Um, cool. If you are here and ready to go, please give me a little GM in the chat, so that we know that you're here. I'm gonna invite our next speaker to the stage now as well. So, welcome to our second workshop of week 2 of the Canto Online Hackathon. I've got Byungchul with me here from Bee Harvest, and you might remember the Bee Harvest team as well, who spoke last week on the topic of Vivacity. But yeah, today we've got Byungchul, who will be talking about Cyclone EVM. Hey, how's it going?
Yeah, good. How are you?
Yeah, I'm doing okay. It's mid-afternoon for me, but I know it's
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 midnight here.
yeah, yeah. So thank you so much for joining us. I guess we're really excited to have you, and yeah, if you're ready, please go ahead and share your screen as well to get prepped.
Okay.
Cool. Hello, everyone in the chat. Yeah, GMGN, depending on where in the world you're in.
Let me share it
Awesome.
again.
Perfect.
Can you see the screen? Oh,
yeah, it's loading. Perfect. Exactly. Oh, we get a sneak peek, a bit of alpha on what's to come in today's workshop. Amazing. Okay, well, yeah, thank you so much for joining us again. And yeah, whenever you're ready, please go ahead.
Okay. Today, I'm going to give a very brief explanation about Cyclone EVM, which the Canto contributors are working on right now for the performance improvement of Canto. The name Cyclone EVM does not mean a single EVM, but refers to a series of tech stack for processing transactions in parallel. So is there anyone who attended the Vivacity session last week? You may have already heard, but let me briefly introduce our Bee Harvest team. Bee Harvest was founded in 2018, starting as a blockchain validator in the Cosmos ecosystem. We are developing DeFi protocols like Vivacity and conducting R&D on Cosmos SDK and EVM. We have also been active as a core contributor since the early days of Canto. Currently, Bee Harvest consists of 27 experts in various fields, ranging from backend, front-end, DevOps to DeFi and TradFi, led by blockchain core team. So let's dive into the Cyclone EVM stack. So here's some background on why we are proposing a high-performance Cyclone EVM stack. So recent years, the blockchain industry have witnessed a significant shift towards high-performance layer 1 solutions, driven by increasing demand for scalable, efficient, user-friendly, and fully decentralized blockchain networks. Projects such as Solana, Avalanche, Aptos, and Sui, have gained considerable attention and success, showcasing the potential of high-performance layer 1 chains to support a wide range of applications from DeFi to NFTs. So these platforms have set new standards in transaction speed, throughput, and overall network efficiency, demonstrating that it's possible to achieve remarkable performance without compromising on decentralization or security. The success of these chains underscores the growing consensus within the blockchain community, which is for a project to thrive and achieve mass adoption, it must offer a high-performance infrastructure capable of handling the demands of both today's and tomorrow's decentralized application. So recently, we have proposed the development of Cyclone Stack, a set of upgrades that will significantly improve the performance and scalability of Canto through the introduction of a parallel execution engine. The Cyclone stack consists of 3 upgrades. The first upgrade is Callisto Upgrade. This upgrade allows Canto to execute transactions optimistically by utilizing ABCI 2.0. I'll explain more about the ABCI 2.0 and optimistic execution in the following slide. The second upgrade is Elara Upgrade. This upgrade includes the Cyclone EVM, which is at the core of Cyclone stack. The Cyclone EVM enables high throughput and sub-second block time by processing multiple transactions in parallel. The final upgrade is Kallichore Upgrade. This modification splits the state store into 2 separate entities. One is state commitment and the other is state store. This is for addressing the issues in the existing storage of Cosmos SDK. The state commitment maintains the active state necessary for consensus, presented as an in-memory IAVL tree. Meanwhile, the state store just stores data for historical queries in raw key value format. This arrangement relieves the existing store's bottlenecks and enhances the speed of various chain operation. After all these upgrades, Canto will stay fully EVM compatible, which means all existing apps and tools will function normally without additional development work. So Callisto Upgrade is about newer version of Cosmos SDK and ABCI 2.0. So let me explain the ABCI. ABCI is an application interface that allows the consensus engine, the underlying command VFD, to communicate with the application. The image on the left explains the operation of ABCI 1.0, and the image on the right explains the operation of ABCI 2.0. In 1.0, it operates in one phase of consensus immediately after a block is finalized. This approach limits scalability improvements and application functionality. On the other hand, ABCI 2.0 allows the application to intervene at multiple points in the consensus execution process. For example, prepare proposal allows the block proposer to perform application-dependent work in a block before proposing it. When the application receives a law proposal through the prepare proposal interface, the application modifies the set of transactions or changes the transaction order. So process proposal is the most important method for improving blockchain performance by enabling optimistic block execution. I will explain this in more details in the very next slide. So the diagram on the left represents a typical block processing process without optimistic block processing. When the block proposer proposes a block, the validators confirm the validity of the received block proposal and conduct a vote on the proposal. Once there is consensus on the block, the transactions included in the blocks are executed in the finalized block step, and finally a commit is made. The diagram on the right describes an optimistic block processing by utilizing the ABCI 2.0 and process proposal method. Once validators receive the block proposal, they optimistically execute the block before the voting process, assuming that the received proposal is valid. Then they record the result in the cache, and if the proposal is accepted in the voting process, they commit the state record into the cache. If the proposal is not accepted, and they increase the round, and then they start a new round. So as you can see from this diagram, this optimistic block processing can significantly reduce the block time because it can be performed in parallel with the voting process. In Cosmos SDK V050, this optimistic block processing is enabled by default, and this is why we have Castillo Upgrade in Cyclone EVM stack. The second upgrade, the Elara Upgrade, is the most core upgrade of the Cyclone stack, which allows for more transactions to be performed simultaneously with optimistic block execution, further reducing block time. So this upgrade will integrate block STM into Canto. Block STM is a parallel execution engine for smart contracts built around a principle of software transactional memory. So the key to the block STM is to ensure that the result of processing transactions in parallel is identical to the result of performing transactions sequentially. So the algorithm for this is quite complex, but let me briefly explain just core concepts. If you want to know more about block STM, please refer to the block STM white paper. So this diagram is a simple representation of optimistic parallel execution. Let's assume that transaction 1, 2, 3 are in one block, and block STM optimistically assume that there are no conflicts between the 3 transactions and execute all the transactions in parallel. After the execution, it performs validation to check if there was a conflict between the transaction. If a conflict occurs, it reverses the corresponding transaction and re-execute it. The re-executed transaction undergoes validation once again, and if there's no more conflicts, then block execution is completed. So the core of block STM is how to detect conflicts between transactions. The picture briefly explains the conflict detection method, technique. So consider 2 transactions. Transaction 1 reads and update the balance of account A and B, and transaction 2 reads and update the balance of account B and C. So if these transactions are running parallel and transaction 2 starts running before transaction 1 has completed, then the balance it reads for account B may be different than if they were run sequentially. So this could result in incorrect results. So block STM solves this by tracking the input, we call it reset, used while executing transaction 2, and comparing them to the output, we call it reset of transaction 1. So if they differ, we have detected that transaction 2 used incorrect data while executing it, and it needs to be executed again with the correct data. So this diagram illustrates the entire life cycle of a transaction in the Cyclone EVM stack. So first step is submitting TX. User submits transaction to Ethereum RPC endpoints. The submitted transactions are arranged in the validator's local mempool. So transactions undergo basic validation such as nonce and signature checks before entering the mempool. Once validated, these transactions are converted into a format that Cosmos SDK can process. So second step is prepare proposal. The proposal selected based on the staking and voting power, the proposes a new block. So during prepare proposal, the app-defined mempool logic determines the list of order of transactions for the block. So simple pre-processing of transactions tags them with like additional information beneficial for optimistic parallel execution, such as dependencies and affected addresses. So once the block transactions are transactions and their order is set, they are sent to the commit BFT for proposing. So third step is process proposal. By default, default process proposal handler just checks the validity of transactions in the block, but we have implemented the extra the logic for the performance improvement. So the other validators execute app-defined logic through process proposal and validate the proposed block. If it's satisfactory, they pre-vote and moving to the next consensus step. So optimistic block processing and optimistic parallel executions are performed for performance improvement. So optimistic block processing pre-execute the transaction during the P2P boot transmission time. It caches the result for used in finalized block stage. So significantly speeding up the block processing. So final step, the finalized block commits the result of in-memory optimistic block processing and optimistic parallel execution performed during process proposal. So the last upgrade, the Kallichore upgrade, improves the Cosmos SDK's store performance. So current IAVL-based storage of Cosmos SDK has several drawbacks. So first one is write amplification, which means the ratio of the actual write size to the amount of usable data. So in case of IAVL tree, it stores the data only into their leaves node. So internal node just stores the metadata. So the size of the metadata is very huge. So the write amplification of current storage system is approximately 2.5. So indicating that this is quite inefficient. The second is storage growth. The write amplification significantly increase disk usage. For example, the SAYS Atlantic 2 testnet, the storage used for archive node grows by over 100 gigabyte per day or 1 terabyte per week, sorry. So as the chain state expand, maintenance costs increase, database operations slow down, and RPC node operation becomes more complex. So last is slow operation. These drawbacks are related to each other. So critical chain level operations such as state sync, snapshot creation, state rollback, these operations have become extremely slow when the chain state sizes surpasses a certain threshold. So to solve this problem, the Kallichore upgrade will separate the SDK storage into two separate stores. The first one is state commitment. So state commitment layer just stores active state chain state data for only for the consensus in a memory mapped Merkle tree. So on the other hand, state store layer is for a full node and archive node. So this state store is designed to handle the historical queries. So this diagram is describing the relation between state commitment and state store. So by separating state store and state commitment, the state store layers handles direct data access in the form of key value pairs. I mean, traditional key value database, no more IVL tree. While the state commitment layer manages block commitments and provide Merkle proofs. This separation allows optimization for the primary use cases and state access pattern. So for state commitment, original IAVL will be replaced with MEM-IAVL, which is in-memory implementation of the IAVL tree. The aim is to ensure all state commitment related operations are fast, reliable, and lightweight. So regarding the state store, pluggable interface will be provided. So this allows a specific application to use any database they prefer, if not using the default implementation. The objective is to establish a scalable, compact, and fast data store for handling historical queries. So currently, we are preparing for the Castillo upgrade and the Elara upgrade. The Castillo upgrade has been fully implemented and is undergoing an internal review for production readiness. As soon as the review and audits are finished, we plan to proceed with the upgrade soon. The Elara upgrade is currently in full swing. The executable POC just finished it this week, and various benchmarks are being conducted for performance optimization. So working on Kallichore upgrade will begin as soon as the 2 upgrades are completed. So the priority is very low for us now. So this is it. I hope the presentation was not too high level. If you want to know more about details, please contact me anytime, and I can take some questions from the audience.
Awesome. Thank you so much, Byungchul. Yeah, we do have some questions in the chat, and I also have one of my own, but we can get to that in a second. So we've got some questions from AJ in the chat. I think your first one has been answered, AJ, with regards to, yeah, how the parallel execution works. I think the second one is what happens if the block is not accepted?
So yeah, when the
Mhm.
block is not accepted during the voting process, and the new round started again. So the proposal will propose a new block, and it will execute the transaction in sequential order. So
Cool.
so parallel execution is done in very optimistic way. So they assumes all the transaction will how can I say, the minimum conflicts are exist in the block. Does it answer the
Cool.
question?
Yeah, I guess so. Great. Yeah, and then the second one, AJ, does anything else do the same thing?
So like this parallel execution is a hot issue in blockchain community. So many are trying to implement this parallel execution. The original block STM was introduced by Aptos, and Say is also implemented their own way of block STM in Cosmos ecosystem. But the Say's implementation is minimized implementation. So what we are trying to do right now is implement a full version of Vlog STM and integrate it into Canto. So the answer is many blockchains are trying to implement parallel execution.
Great, awesome. I think that makes sense. Cool. My question, I guess, was or is going to be, how long does it take to kind of make an upgrade like the ones that you were speaking about? I think the Elara, right, was your second?
Yeah, Elara
Yeah.
will take like couple of months from now. So we are like our all core developers are working on this in full speed, but it will take minimum couple months from now, excluding the audit process.
Yeah, that makes sense. Is that just for the Elara stage or also for the last stage as well? For the last upgrade, I mean.
Why Canto out of all the elements? What does it mean exactly?
AJ, do you want to elaborate on that question? Yeah. Okay, I think AJ is
Yeah, he's
typing.
typing.
Yeah, awesome. Cool.
Why choose Canto? That's a very difficult question. But since we contributed to Canto from the very early stage, and because we don't have our own chain, but we have high R&D capability, so we continue to contribute to the Canto to experiment our R&D result. That might be the answer for your question.
Yeah, great. Cool. I guess kind of on the back of that question from AJ, what are your kind of favorite things about the Canto chain that you really enjoy when you're kind of working with it, when you're building on top? What are
So
things that you're like, what's great?
In BRVest, we are researching a lot of field topics in blockchain community. For example, the GK lookups and this parallel execution, everything. When we propose our new idea to improve the chain, they accept. How can I say? They never say no. So like they try to evolve very quickly. So that's why our team likes Canto.
Yeah, no, I think that's a really great answer, especially for all of the hackers in the audience or anyone watching this later. I think it's good encouragement to know that the team are open for anything, and generally in terms of projects, you guys can build whatever you'd like, and make sure to ask the Canto team for help as well. Cool. Are there any other questions from the audience? Anyone else have a question? Great, AJ, thank you. Glad that you enjoyed it.
I will leave my email.
I think that would be
So
brilliant, yeah.
if you have any question about these upgrades or status, just send me an email.
Cool, awesome. So that's be.park
Sorry, it's BC
oh,
Park.
BC, sorry,
Yeah.
bc.park@bharvest.io.
Yeah.
Just reading that out for anyone watching this recording, just in case. Yeah, awesome. Thank you so much, Byungchul, for coming along. Thank you
No
for
problem.
speaking. It was a really great explanation of the Cyclone EVM. So yeah, anyone who wants to get involved later on, please do reach out. Awesome. Thanks,
Oh,
Dale.
by the
Really
way,
appreciate
we are targeting like 5,000 TPS. Just
it.
for your
Okay.
information.
Wow. That's quite a lot, isn't it? That's awesome.
Yeah. It's very
Yeah.
high number.
Yeah. Well, guys, all the more reason to get involved. That's awesome. Yeah. Cool. Well, thank you so much once again, and thank you all for coming along to this workshop. I will see you all offline, but in the chat. So see you all soon. Thank you so much again,
Okay.
Byungchul.
Yeah,
Thank
thank you,
you.
Angela.
Bye.